Hi guys, I am Manish. Today we are going to discuss a topic in computer networks. It is distance vector routing protocol. What is distance vector routing protocol? Distance vector routing protocol is intra-domain routing protocol. First, what is an intra-domain routing protocol? Suppose in an autonomous system there are many routers available. Among those routers, the information is shared using this intra-domain routing protocol. That means some packets or messages is shared between the routers, right? That sharing process is done using intra-domain routing protocol. Now we'll discuss what is distance vector routing protocol. Suppose in a network there are 5 routers: N1, N2, N3, N4 and N5. These routers are connected with the links. These are the links through which these routers are connected. Now these routers will share the information, and every router will update it that what is going on in this network. Now let us suppose N1 want to send a packet to N4. So what we need that shortest path to send packet from N1 to N4, right? That shortest path will be given by this distance vector routing protocol. How this distance vector routing protocol gives shortest path, we'll see now. For every router, there will be a routing table. For every individual router, there will be a routing table. What is routing table first? The routing table contains of 3 components. First one is destination. What is destination? If N1 want to send a packet to N5, N1 want to send a packet to N5. That means N5 is the destination here. And distance. Distance is what is the distance? What is the distance to travel that packet? That means if N1 want to send a packet to N2, that means the distance is 1. It may be called distance in some problems. It may be called cost in some problems. It may be called delay in some problems, like that. What is next? After that packet is transferred, what is the next node? If N1 is transferring a packet or sharing some information with N2, that means that after that sharing information, the next will be N2. Next node will be N2. Now in this distance vector routing protocol, there are 2 main rules. First one is every router will know that how many routers are available in the network. That means N4 will know that there are 5 routers in the network. N3 will also know there are 5 routers in the network. That is the first rule. The second condition in the distance vector routing protocol is a router will only know about their neighbors. That means N4 only knows N3 and N5. N2 only knows N3 and N5. That means N4 only know N3 and N5 how much distance from this router. That means how much delay or how much cost it takes to transfer a packet from N4 to N3. The second condition in the distance vector routing protocol is every router will know about their neighbors only. That means N2 knows about N3 and N5. N1 knows only N2. N4 knows about N3 and N5. That means N4 knows how much distance is between N4 and N3 and how much distance is between N4 and N5. It only knows about their neighbors only. This is the second condition. Okay. Now we'll write the N1 routing table. Okay, this is the destination here. It means N1 has to go to N1 from N1. That means what is the distance? 0. And what's the next node? N1. We'll call this as nodes. That's why we named this as N1, N2, N3 and N4 and N5. Now N1 has to go from N1 to N2. What's the distance? Is 1. And what's the next node? N2. Is there any direct link from N1 to N3? No. So N1 n3 is not the neighbor of n1. So n1 cannot know about n3. So its distance is infinity. And what's the next state? We don't know. Now we have to go from n1 to n4. Is there any direct link from n1 to n4? No. Means n4 is not the neighbor of n1. So it will not know about n4. So it is infinity. What is the next state? We don't know. And n5. Is the n5 the neighbor of n1? No. So n1 cannot know about n5. So it's also infinity. And what's the next state? We don't know. This is the n1 routing table. Now we will write the routing table of n2. Now we have to go from n2 to n1. What's the distance? 1. And what's the next state? n1. Now we have to go to n2 from n2. So distance is 0. And what's the next node? n2. We have to go to n3 from n2. That means we have a direct link. That means n3 is the neighbor of n2. So it can go from n2 to n3. What's the distance? 6. And what's the next state? n3. Now we have to go from n2 to n3. Is there any direct link from n2 to n4? No. That means n4 is not the neighbor of n2. So it cannot tell about n4. So the distance is infinity. Now we have to go to n5 from n2. Yes, we can go to n5 from n2. What's the distance? 3. And what's the next node? n5. Now we'll write the routing table of n3. We have to go to n1 from n3. Is there any direct link? No. That means n1 is not the neighbor of n3. So it cannot know about n1. And now we have to go from n3 to n2. As there is a direct link. So the distance is 6 and the next node is n2. Now we have to go to n3 from n3. That means the distance is 0. And the next node is n3. Now we have to go to n4 from n3. There is a direct link. That means n4 is neighbor of n3. So we can go. What's the distance? 2. The next node is n4. Now we have to go to n5 from n3. Is there any direct link? No. There is no direct link. So n5 is not the neighbor of n3. So we cannot know about n5. So the distance is infinity. The next node is we don't know. Now we will draw the routing table of n4. First we have to go to n1 from n4. Is there any direct link? No. So n1 is not the neighbor of n4. So the distance is infinity. We have to go to n2 from n4. Is there any direct link? No. So it's not the neighbor of n4. Then the distance is infinity. And we have to go to n3 from n4. As we can go. That means now the distance is 2. And the next node is n3. Now we have to go to n4 from n3. So the distance is 0. And the next node is n4. Now we have to go to n5 from n4. There is a direct link. So n5 is the neighbor of n4. Now the distance is 4. And the next node is n5. This is the routing table of n4. Now we will write the routing table of n5. First we have to go to n1 from n5. Is there any direct link? No. That means the distance is infinity. We have to go to n2 from n5. There is a direct link. So the distance is 3. And the next node is n2. We have to go to n3 from n5. Is there any direct link? No. There is no direct link. So n3 is not the neighbor of n5. So the distance is infinity. We have to go to n4 from n5. Yes, we can go to n4. Then the distance is 4. And the next node is n4. We have to go to n5 from n5. That means the distance is 0. And the next node is n5. This is the routing table of n5. Now, these all routing tables will run parallelly. That means these all routing tables we will know parallelly. That means at a time these all values will be done. Now, these are the distance vectors of 5 routing tables. This is the distance vector of n1 routing table. This is the distance vector of n2 routing table. This is the distance vector of n3 routing table. This is the distance vector of n4 routing table. This is the distance vector of n5 routing table. Now we are entering into the second cycle of the question. There are two conditions in the second phase of this problem. That is, every router in the network can only share the information of routing table with the neighbor only. That means n2 can only share with n1 and n5. n3 can only share with n2 and n4. n1 can only share with n2. In that way. The second condition is, every router can only share distance vector only. It cannot share entire routing table. It can only share the distance vector of the routing table. And now that means n1 can share the distance vector of n2, and n2 can share the distance vector of n3, n5 and n1. n3 can share the distance vector of n4 and n2. And n4 can share the distance vector of n3 and n5 because these two are the neighbors. Now n5 can share the distance vector of n2 and n4. Now we'll create the new routing table of n1. So for new routing table of n1, we will use the information of n2 distance vector. Now we have to go to n1 from n1. Obviously the distance is 0. And the next node is n1 only. Now we have to go to n2 from n1, and we have to use this n2 distance vector information. That means the path is, we have to go to n1 from n2 and n2 to n2. Okay, what is the distance from n1 to n2? That is n1 to n2, that is 1. Plus, what is the distance from n2 to n2? n2 to n2, that is 0. So the total distance is 1. And the next, what is the next node? n2. And next, we have to go to n3 from n1. So what's the path? We have to go to n1 to n2 and n2 to n3. Right? What is the distance from n1 to n2? n1 to n2 is 1. Plus, what is the distance from n2 to n3? n2 to n3 is 6. Because we have to use only n2 distance vector. What is the total distance? 7. Distance is 7. Now we have to go to n4 from n1. So what's the path? n1 to n2 and n2 to n4, right? Now what's the distance from n1 to n2? That is 1. And what's the distance from n2 to n4? Look, this is infinity because there is no direct path from n2 to n4. That's why the distance is infinity. So what's the total distance? Infinity only. And what state we don't know. And we have to go to n5 now. So the path is n1 to n2 and n2 to n5. What is the distance? 1. n1 to n2, 1. Plus, what is the distance from n2 to n5? n2 to n5 is 3. So what's the total distance? 4. The total distance is 4. The next node is n5. This is the new routing table of n1. In this way, we have to, in the second cycle, every routing table will be updated. Like n1 routing table is updated in this way. n3's routing table also will be updated using n4 and n2 distance vectors. n4 routing table will also updated using n3 and n4 distance vectors. n2's routing table will also be updated using n3, n5 and n1 distance vector. For n2 we can use distance vector of n3, n5 and n1 because there are 3 neighbors to n2. Now for first we have to go to n1. So what's the path? The path is like there will be 3 different paths because there are 3 different distance vectors available for n2. So the first path will be, it will go from n2 to n1, and the second path will be, it will go to n3 to n1 and it will go to n2 to n3 and n3 to n1. The third part will be, it will go from n2 to n5 and it will go from n5 to n1. Now what is the distance from n2 to n1? n2 to n1 is 1. What is the distance from n2 to n3? n2 to n3 is 6. Plus what is the distance from n3 to n1? n3 to n1 is infinity because there is no direct link between n1 and n3. So the distance here is infinity. What is the distance from n2 to n5? n2 to n5 is 3. Plus what is the distance from n5 to n1? n5 to n1 is infinity because there is no direct link between n5 and n1. So the distance is infinity. Out of these 3, which is the shortest one? This one, 1. So we'll take this. So here 1. What is the next state? n1. We have to go to n2. n2 is 0 because obviously this will be the shortest, right? However we go, this will be the shortest. Okay, now we have to go to n3. Now first one is, we have to go to n2 to n3 and n3 to n3 only. The second path is, we have to go to n2 to n5 and n5 to n3. And next last path is n2 to n1 and n1 to n3. These are the 3 paths. Okay, we missed something here. After going to n1, we have to go to n1 to n1. That means plus 0, that equal to 1. Same thing. Now, what is distance from n2 to n3? n2 to n3 is 6. Plus, what is the distance from n3 to n3? 0. That is 6. What is the distance to n2 to n5? n2 to n5 is 3. Plus, what is the distance between n3 and n5? n3 and n5 is infinity because there is no direct link between those two. So the total distance is infinity here. The distance between n2 and n1 is 1. Plus what is the distance between n1 and n3? n1 and n3 is infinity because there is no direct link between them. Equal infinity. Out of these 3, what is the smallest one? This is the smallest one. So we'll write this thing. And next is, we have to go to n4. And there also we have 3 paths. The first path is, we have to go to n2 to n3 and n3 to n4. And next path is n2 to n5 and n5 to n4. The next path is n2 to n1 and n1 to n4. Now, what's the distance from n2 to n3? n2 to n3 is 6. Plus, what is the distance from n3 to n4? n3 to n4 is 2. Here distance is 8. Now, n2 to n5. What is the distance? n2 to n5 is 3. Plus, what is the distance from n5 to n4? n5 to n4 is 4. This is 7. What is the distance from n2 to n1 is 1. Plus, what is the distance from n1 to n4? It is infinity because there is no link between n1, n4 and n1. Out of these three, which is the smallest? This is the smallest, right? So we'll take this distance. We have to write for n5 also. For n5 also there are three parts. The first path is, we'll write here. The first path is n2 to n3 and n3 to n5. What's the distance here? n2 to n3, 6. Plus what is n3 to n5? n3 to n5 is infinity because there is no direct link between them. The second path is n2 to n5 and n5 to n5. What's the distance to n2 to n5? n2 to n5. That means 3. Plus what is the distance from, okay, we'll write here. What's the distance from n2 to n5? 3. Plus what's the distance from n5 to n5? 0. That equal to 3. The last path is n2 to n1 and n1 to n5. What's the distance here? 1. Plus what's the distance here? Infinity, because there is no direct link between n1 and n5. Equal to infinity. Out of these three, this is the smallest one. So we'll take this thing. So this is the new new routing table of n2. Okay. In this way, we have to find for n1, n2, n3 new routing table of n1, n2, n3, n4, and n5, so on. We have to repeat this process until we get the shortest paths. Like we have to repeat this process many times. Like after coming new routing tables of all the 5 routers, and again we have to take the adjacent distance vectors and we'll complete that. And when we have to stop this process when we get all lowest values, that means shortest distances to send the packets from one router to the another router. That means we have to eliminate all the infinities. Then only we will get the shortest path to send the information from one router to the another router. Exams or some gate type of exams, we need shortcuts, right? So by seeing this network, we can say directly what's the shortest distance we will do. I will tell you that process also now. Now we have to go to from n1 to n1. What is the shortest path? Obviously 0. And we have to go to from n1 to n2. There is only one way to go to n1 to n2. That is this one. And what is the distance? 1. This is the shortest one for n1. And we have to go to n3 from n1. There are two ways. We have to go to n1 to n2 and n2 to n3. This is one way, one path. And then another path is we can go to n1 to n2, n2 to n5, n5 to n4, n4 to n3. But obviously this process is long. You can see now. You can see this process is of like 1 plus 3, 4, 8, 10. This is only 7. So we'll take which one? This one. This is the shortest path, right? So we'll take this one. And we have to go to n4 from n1. There are two ways. This one and this one. Like we have to go from n1 to n2, n2 to n3, n3 to n4. And the another way is we can go to n1 to n2, n2 to n5, and n5 to n4. In this way, the distance is like 8. In this way, the distance is 9. We'll take the shortest one. This is 8, right? So we'll take 8. And we have to go to n1 to n5. Here also we have two paths. One is we can go from n1 to n2, n2 to n3, n3 to n4, and n4 to n5. And the other path is n1 to n2 and n2 to n5. This is the shortest one, right? This is only 4, and whereas this is 7, 9, and it's all 11. So this is shortest one. So we'll take this one. Okay, thank you. Stay safe, stay home.